All right, recording is rolling. Welcome to Friday, October 20. So a bunch of guys just turned your chapter 6, 7 puzzles. Thank you for doing that. I'll get those in the grade book for you soon. You guys know quiz due Monday. This is circular motion, centripetal force, gravitation, orbits. All right, so due Monday. Got a project lined up for you guys today. First, you guys that there's over this weekend, there's going to be a meteor shower. Yeah, so if you guys are keeping an eye on the sky, yeah, you might see some meteors.
What days?
I think just this weekend in general. Yeah, usually like a couple of days, I think.
What
So
about Sunday?
I have to look that up. I think Sunday probably. I have to Google that for sure. I just heard this weekend. Yeah, so check that out. Oh, O'Neill cylinder. So you guys remember probably a couple weeks back? I think I played you guys a clip from 2001: Space Odyssey. Actually, go ahead and roll it again. Right?
Yeah.
So if you have this cylinder out in space where actual gravity fields might be negligible, right? You can spin this, and everyone on the inside will maybe experience some artificial gravity, right? Really, there's a normal force from the wall acting as a centripetal force, right? And if you know the radial size of this thing, you can calculate how fast to rotate it, angular velocity, like radians per second, so that everyone experiences some target value of this artificial gravity. Maybe you could target like 9.8 meters per second squared, might be a good value. So, switch my screen over. All right. Oh, here's artist rendition of what this might look like. I'm gonna set you guys up with a project where about to be where I'll probably leave this on the screen most of the class, right? Let's look at some other ones, some other artist renditions, these things where we're looking at these cross sections, right? Like, I wonder what you need up in space if you were like inhabiting a space, right? Now, right now, it's really expensive to get stuff in space. That's the only reason we don't have stuff quite like this. Oh, these are just aerial views of like Manhattan, just to give you an idea of like an aerial. All right. Oh, no, did that not? Not gonna. Okay, never mind. Okay, right. Oh, what was it saying here? Okay, so I'm gonna have you guys design these O'Neill cylinders. There was a video rolling, it just cut out. I don't know what just happened. Let me see if I can kind of play that again, right? Because in the past, all right. All right, yeah, in the past, it looks like this was about from 3 years ago. I've had students create individual panels, and we glue them together and create a giant O'Neill cylinder for the class. I'm gonna do a little bit different this year. I gave you guys small strips of cardstock so you can make one individually. I'm gonna flip my screen so you guys can see that too. But it's the same premise, right? Like you can say, well, what could you have in space? Oh, that's my train of thought, right? So right now we don't have things like this in space just because it's so expensive to get stuff into space. But like 500 years from now, I could totally see there being like these space habitats, right? And what kinds of things you want on it? Well, maybe like places to live, places to work, places you probably want like good water source, probably recycle a lot of things. It's probably still expensive to transport things in and out. Right? And so here's some aerial shots for some past examples. Ooh, creativity going on here. Right? So yeah, see like space theme parks. That's a fun idea. Okay. Let's go back to. All right, back to these artist renditions. Might look something like this. Right. Now the trouble actually with making one really long like this is it wouldn't actually be stable. So let me mention that too. I'm going to switch my screen back over and show you guys an example of like what you don't actually want long cylinders. You want more like a wide cylinder. Like this would be stable. Like this is kind of like a wide cylinder, like more like a disc looking shape. So gonna flip back over here. Okay. So like my poster version would be stable, but you don't want like a long cylinder rotating about that central axis. There's something called intermediate axis theorem. It would never actually be stable if you have people walking around. It would just like change axis. Okay? So this is kind of an abstract form of physics. Kind of a weird corner. I haven't tried my other class of this, so I'll just show this to you guys. If you have a cell phone, you can try this out. You can flip it so that it will rotate stably along different axes. There are different axes that it could possibly rotate about, right? Like for example, what about like an axis that goes perpendicular to the surface, right? Like you could spin it about that axis, right? Okay, and it would set up all stable, right? So no problem there. Right? You could also, what about an axis that runs long ways like this, like a long axis, right? Yeah, you could spin it like that. But if you want a real challenge, I can tell you something that I can almost guarantee for sure you cannot do. Right? I bet that you guys cannot rotate it around this axis right here, like make a clean flip. Like if you try to flip it like this, I've got a small confined space here, but let's just get the idea across, right? If you try to flip it like this, like I guarantee it's not gonna go make a clean flip all around like that. It always does some like weird like half turn, right? It'll never actually make a clean flip, right? It's a weird explanation why. If you're interested in that, look up something called intermediate axis theorem. This is a side thought in what we're doing today, right? But it is kind of related to like how could you build a cylinder that actually would be stable? So all the having is like why space? Okay. So for you guys have these strips of card stock. I'm gonna have you guys here. Let's demonstrate this first part. Glue two of them together. I'll do one of them in front of you guys. This idea. All right, throw a dab of glue right here. Okay, get that straight. Okay, if you press and hold that about 20 seconds, that should dry. Right. And then eventually you can loop this around to make a cylinder. Oh, that's gonna look a lot like the one on the poster, won't it? Right. Now you don't want to glue it before you draw your artwork on the inside. Right now, here's where you get to use your imagination, draw whatever you like to draw. I've got some good examples from earlier. I'll pick at least one and show you. Right. Yeah. So this one looks pretty good. We got a space stadium here. I've got two different cameras I'm trying to present to you, right? Got the video at home and I got the projector for you guys in class. Two little bit different angles. Okay. There's I see a bakery, I see some buildings look like they might be some kind of housing something. Yeah, those look like houses. Oh, we've got a park. Oh, a space park. All right. All the way around. So there you go. Right. That's a pretty good example right there. Right. So use your imagination, work with your friends. Think, what do I want in my my O'Neill cylinder space habitat? And rest of class, I will go ahead and leave up this graphic on the screen. Yeah, so enjoy that. All right, last detail. Look this up on the internet. Seeing this is from CNN. It says the meteor shower this weekend is expected to peak at 8 p.m. Eastern time Sunday. So yeah, actually Sunday night would be the best time to see the meteor shower. All right, so Sunday night. All right. Yep, Sunday night's the best night to see the meteor shower. All right, with that, that's gonna be a wrap on the recording and going into the weekend. Oh yeah.